So hi everyone. Today we will be understanding how Lime, a very popular method for interpreting machine learning models, works. So as we discussed in my previous video about PDPs, Lime also follows on the same line as it is an agnostic method for interpreting machine learning models. By agnostic, we mean that irrespective of the model that we are using, be it a neural network or decision tree or SVM, etc., it is able to interpret everything. So let's understand what is the method behind this and how what is the mathematics that goes in. So first of all, assuming that you have trained we are assuming that we have trained a neural network on a binary classifier with a tabular training data set where we have four features only. So basically four features A, B, C, D, and a target class that is binary in nature. So first of all, after training the neural network, first of all, you need to generate summary statistics for the training dataset features ABCD that we are talking about. Now, how to generate the summary statistics for numerical features? It can be mean and standard deviation per feature, or for categorical, it can be frequency for each category, etc. Now, this can be anything. Depend like if you go for Scratch implementation, it can be anything. But but in the paper they have mentioned like numerical features should have a summary statistic with mean and standard deviation, and categorical data should be represented by frequency of each category, right? Now, using this summary statistics, we need to generate an artificial data set. How to do that? So Lime assumes that each feature has a Gaussian distribution. So for numerical features, it's pretty easy. You got the mean and standard deviation earlier, so you can generate random samples out of it, assuming the distribution for each feature is Gaussian in nature. Similarly, for a categorical data set also, you can have a probability distribution. As earlier in the previous step, you have already calculated frequency for each category. Like, for example, good has 5, bad has 10, very bad has 15 samples. So eventually, you can calculate the probability for each of this category by following the formula small n upon big N, where small n is the samples for each category X, and big N is the total number of samples. So using this probability distribution also, you can fill in the random values of categorical data set. So once you are able to calculate this artificial data set, you need to pick up a random sample from the original data set. Now let's call it X. Now the next step is to provide weights to the samples in the artificial data set using this particular sample that we have picked up. Now these weights can be assigned in two ways. One is a basic way would be distance. So the artificial data set that we have created, the samples present in it, the farther they are from the random sample that we have picked, lesser the weight is. The second thing can be done is a kernel width method, where samples falling in a particular range of the sample X are given higher weights, else they are given lower weightage. Now, once you have given weights to each of the samples in the artificial data set, you need to fit in a white box model now. A white box model means, if you have missed out on my previous videos, a white box model is a simple model that is interpretable by multiple methods. Interpreting such methods is pretty easy. Like, for example, linear regression. So for interpreting linear regression, what you can do is that you can go and check out the weights of each feature. So using this weights, you can know that okay, this particular feature is more important as compared to other feature. Similarly, one of our previous videos, you can check out how decision tree feature importance can be calculated. So all these methods are white box method, where interpretation is easier as compared to black box method. So what we did is that on the weighted samples that we have generated in the artificial data set above, we are trying to fit in a white box model. And as white box models are easier to interpret, the interpretation of this white box model would be considered as the interpretation of our black box model also.